Okay, so this is May 2008, question 4. Now we're given two particles, P and Q, which are moving along the same straight line. Particle P starts at rest with initial velocity 0 and has a constant acceleration of 0.5 towards Q. Particle Q starts with an initial velocity of 10 meters per second at a distance of 125 meters away from P, and it has a constant speed of 10 meters per second away from P. So both objects are moving in the same direction. This one begins at rest, this one begins with a velocity of 10 meters per second. This one is accelerating and this one is travelling at constant velocity. So clearly what will eventually happen is this particle is going to catch up with this particle when its velocity is fast enough, and then it will overtake it. So part 1, write down the expressions for the distances travelled by P and Q at time t seconds after the start of the motion. Alright, so for particle P, the distance travelled is going to be given by, so for P, using s equals ut plus a half at squared, gives us s is equal to ut, which is 0 times t, which is 0, okay, and then a half at squared, well hang on a second, a half of a is 0.25, and t squared is going to be, well, just leave it as it is, 0.25 t squared. Now, for the other particle, we're going to say the distance it's travelled from P. So again, for particle Q, we're going to use s equals ut plus a half at squared, but it has a 125 metre head start. So it's going to be s equals 125 plus ut plus a half at squared. And so that's going to give us s equals 125 plus 10 for u, so 10t, and there is no acceleration, so this bit will just be 0. So we have that. Okay. Then we move on to part 2. How much time does it take for P to catch up with Q, and how far does P travel in this time? Well, when P is caught up with Q, we know that the distance of both particles from that point will be the same, because they're at the same position. So we can find the time at which the position of both particles from here is the same by putting this equal to this. And so that gives us 0.25 t squared equals 125 plus 10t. We can then rearrange that to give a quadratic. And if we then solve that quadratic, we get the solution of t is 50 or t is minus 10. Now clearly, we can't have time of minus 10. So that must mean that it happens when t is 50. And the final part of the question, how far does P travel in this time? Well, again, we can use s equals ut plus a half at squared. And if we use that, we can solve it to find that we have, or rather even we can just use this actually, can't we? And we've got that s equals 0.25 times 50 squared, and that gives us an answer of 625 meters. So just recapping, to find when one particle catches up with another, we find an expression for the position of each particle from the starting point of that particle there. So that was here and was here. We put those equal to each other and solved it to find when they're at the same position, and then we can use that time to find how far that particle has travelled by substituting that value into that expression there. And that's the end of question 4.